The system is composed of a base of real components and of an interface for data acquisition. Let's see how it works through a simple experiment, the Ohm's law. Let's connect the system's board for the exercise. This is done by following the instructions and the diagrams in the experiment manual. And now we can start the software. We choose the voltage and save data in a table. Then we change the resistor and make the same. If we are not happy, we can delete the saved results and start again. Graphs are automatically drawn and data can be easily compared. We can hide or show the cursor, and through it we are able to read the actual values on the graphs. Once we decide to finish the exercise, we can ask for the generation of reports. Reports are in the form of text.txt files, Excel tables.xls files, and documents.doc Word files. Let's make another exercise, the diode as a rectifier. Once again, we make all the connections according to the diagram provided in the experiment manual. As you can see, the operation is easy and user-friendly. It is just a question of following the instructions. We can now run the software, which is provided with a virtual function generator whose frequency and amplitude can be changed by the user. We can also freeze and save as snapshots the diagrams, in this case without capacitor. We now choose the first capacitor and take the relevant snapshots of its diagram. We then choose a second capacitor. And again we save its diagram. Lastly, we choose a third capacitor, and once again we freeze and save the relevant diagram. We finish the exercise, and TXT, Excel and Word reports are generated. Let us now investigate the operation of the virtual instrumentation, and let's start from the oscilloscope. We can change the frequency as well as the amplitude of the function generator, and then we can choose the time division and amplitude division of the oscilloscope. We can freeze the graph, change the parameters, show or hide the cursor, and see the fast Fourier transform of the signal. Another possibility is to use the digital inputs and outputs that are available on the base of the system. Having physically connected digital inputs 03 to digital inputs 07, we select digital inputs 03 as output, change its status, and check the interconnection between the two. Let us now perform an exercise in thermodynamics. We will use the temperature and pressure sensors of the kit. As usual, we make the connections on the system board, and we can connect a syringe to the pressure sensor. While operating on the syringe, we are able then to record the values of pressure and temperature of the air inside the syringe and draw the graph of pressure against volume, saving the values anytime we want. Data can be also saved in a table. Finally, let's make an exercise of chemistry. We want to measure the change in the value of the pH when a timed release tablet of vitamin C is put in water and let dissolving. As you can see, a time diagram is generated for further evaluation.